Chapter 1, Section 6, Subtraction of Real Numbers. We're going to talk about opposites and additive inverses, which are pretty much the same. Then we got subtraction, and then we're going to do some problem solving. So in arithmetic, when a number b is subtracted from a number a, the difference, which is the answer to a subtraction, we'd write as a minus b. And it matters, basically they're going to say that it really matters the order, and then they bring in this idea of replacing it with addition, and it's kind of like how they dealt with division when they were saying, well, think about the multiplications and stuff like that, because supposedly we've all memorized our multiplication tables. So, well, kind of the same idea they're going through here. But let's drop to this some of the definition of terms. And again, I can't emphasize enough, they don't start defining words unless they have some real reasons to do that. And the focus is on to be able to explain why we can do some things. And at first, it's very easy. It seems kind of like, wow, that's pretty obvious. But we're going to focus in on these additive inverses to strategically be able to do a lot of things in algebra. So because we've already defined what the additive inverse or identity is, 0, and we're going to be able to get zeros from these additive inverses. So to find the opposite of each number, like negative 34, or 34, excuse me, the opposite of that is negative 34. And the way you can prove that really is, if they're really truly the opposites, when you add them together, they get to 0, which is the additive identity. And we can also say the opposite is 0 is 0, because when I add 0 plus 0, I get 0. To write the opposite of a number, we use the symbol negative as follows. Now, this is, to me, seems like kind of a waste of ink, but they got opposite or additive inverses. If the number a is written as negative a, reading the opposite of a, or the additive inverse of a. And basically they're saying here, this works for all numbers. You know, we show it works for the like 8.3 and negative 8.3 and so on, but it works for everything. And I'm going to bring in one more caveat to this opposite. If you wanted to multiply something times 3 to give you the opposite of 3, what would you multiply by? And it'd be a negative 1. So really, multiplication of negative 1 is the same as taking the opposite of, and of really means multiplication when we were going through our terms, or doing the additive inverse of a, or times a, would be like multiplying a negative 1 times a, and you're going to get negative a. So here's where we get a lot of confusion, and there's a lot of problems around negatives early. I see a lot of errors around negatives, so we need to get real clear about what's going on here. So if I find here, this example, they want us to find the negative of x, and or the opposite of x, or the additive inverse of x would be the way to say this 3 different ways, right? Or a fourth would be a negative 1 times whatever x is. Here I have the opposite of x, or the additive inverse of the additive inverse of x, or negative 1 times negative 1 times x would be another way to say this. So they want to evaluate this expression when we put in 16 for x. And a good way to do this is to put in parentheses around the variable, and then I'd have the negative of, or negative times the parentheses of 16 in the middle. In other words, I get negative 16. So if I have, in this case here though, I have the opposite of 16. I put that in here, and I'm going to be back to a positive. And when we get into multiplication rules with negatives, which they're not really explaining here, if I think about these as multiplications of negative 1, the way to determine the sign of a multiplication is to count the negatives, and if they're even, we can pair those up to be positives. I'm going to end up with positive pairs, and I end up with a positive result. If they're odd, I'm going to have one more negative left off. After I pair up these negatives, I end up with a negative result. So it says for any real number a, the negative of a negative a is that a, or the opposite of a. What is a negative 1 times negative 1? That's 1. That's the identity. Okay? So a lot of ways to prove this is to actually put in the numbers for what that negative really means. Now, here's where we get in trouble. Well, this means the opposite of, the additive inverse of, or the negative 1 times whatever x is. So if I put this in, a negative 3 in for x, here's where I was talking about this parenthesis. Well, I want the opposite of negative 3, which is positive 3. Or probably the best way is to write it out this way. The negative of a negative 3. Or negative 1 times negative 3 would be another way to do that, which is a positive 3. Now the opposite of negative 3. Put this in the parentheses the right way. And now how many negatives do I have? If I was thinking of negative 1s again, it's negative 1 times negative 1 times negative 1 times 3. I end up with a negative result. Okay? So I'm kind of jumping ahead, but there's like 3 different ways to look at how we're dealing with these negatives. So this idea of putting parentheses around the variable can be really crucial, like especially with something like this, okay, to show what's going on. Now subtraction is really adding the opposite, and we're going to talk about additive inverses again. There's a way to they're going to get to is actually we can change subtractions into addition, which is going to be crucial when we're talking about terms, because terms in an expression are the parts that are added, right? Well, if I have subtractions going on, then I don't know what my terms are until I look at it as an addition. Then I know what my terms really are. And so they're going to do some things like this, and usually in class I'll write up something like I don't see an example right here, but I'll put like 5 minus a negative 3, and I'll ask what's the answer to that. And if you know how to convert subtractions into addition, you end up with 5 plus 3 is equal to 8. But I get all kinds of answers, negative 2 and 2 and other things, because you don't know how to really deal with subtracting negatives. And that's what they're trying to point out here, is negative 5 minus a negative x should read the negative 5 minus the opposite of x, and so on. Okay? Well, 2 minus 8 is a negative 6. You'd go, it's kind of like if I drew a picture of this, I'd start at 0, I go 2 to the right. Well, subtracting 8 means I go back to the left 8, and I'm going to end up at negative 6. Guess what? That's exactly the same as 2 plus negative 8, right? When we think about direction on a number line, subtraction is the same as adding a negative number, in a sense, if it's positive, okay? So if I have t minus a negative 4, it's really, I'm going to write that, and they're really basically what all they want us to do is translate this into English. I would say that as t minus a negative 4. This one would be negative 6 minus the opposite of x, or negative x. Then they give us this law of opposites. For any two numbers, a and negative a, if I add those opposites together, I get 0. Remember, I told you this was coming. This is additive inverses will add up to 0, the identity of addition. Just like when I have reciprocals for multiplication, the definition of reciprocal is when I multiply those two numbers together, I get 1, which is the identity of multiplication. So here it is for addition, is we have these opposites or additive inverses and doing that. Then they talk about a positive number is said to have a negative number, is said to have a negative sign. A positive number has a positive sign, which we usually don't show because we basically write a lot of positive numbers. So rather than have to put a plus in front of it to represent that, we just leave it blank, which is going to be, means it's positive. Example 5, they want us to change a sign or find the opposite of each number. So what is the opposite of negative 3? Or another way to say, what is a negative 1 times negative 3? Or what is the additive inverse of negative 3? 3 different ways to look at that, which is 3, right? So I change the sign in negative 10. If I want the opposite of negative 10, it's 10, or the additive inverse of negative 10, or negative 1 times negative 10. I end up with 10. And if I want the opposite of 14, that's negative 14. The additive inverse of 14 is negative 14. Negative 1 times 14 is a negative 14. Subtraction. Now they go into this reasoning thing here to say, you know, there's a relationship between addition and subtraction, which we know about and everything else. But the key thing here is I want to find out, you know, remember how, what do we do with division of fractions? Is we convert it to a multiplication by taking the multiplicative inverse, which is the reciprocal of the second number, the divisor. Well, in this case, we can take this, the part that's being subtracted here, 5, and change it to its opposite, which would be negative 5, and change the subtraction to an addition. Or in other words, we change from subtraction to addition by adding the opposite. So 9 minus 5, I would think is probably just fine the way it is. We're used to that's 4. Everything else, I got that. But actually, if I took 9 plus a negative 5, you're going to get the same result. 5 minus 8, you might be perfectly fine too with saying, hey, I go 5 to the right and 8 back, I get the negative 3. But that's exactly what you do with this addition again. And I'd get the negative 3. Here's where I see, if you do not change this to an addition, I see all kinds of error. When we're subtracting a negative number, it gets confusing until you change it to an addition, which is add the opposite. So negative 7 minus a negative 10, I'll get a lot of answers when it's left in subtraction. People will think that that's negative 17. But when I change it to an addition, which is negative 7 plus its opposite, which is 10, that negative 17 answers go away. I look at this, hey, it's going to be positive because this is, you know, I went further to the right than I went to the left, and it's going to end up at 3. Same thing here. If you see subtraction of negatives, change to addition. In fact, I'll go one step farther. If you see subtraction, change to an addition. Why would I say that? It seems like an extra step, but what does subtraction what does addition have that subtraction does not have? Is the commutative, the associative laws, which allows me, the commutative allows me to change order, and the associative allows me to change grouping. That does not work on subtraction, but it does work on addition, which can give me more opportunities to problem solve. I have more tools that I can use when it's in addition. And that's this law, that I can change any subtraction into an addition by adding its opposite, or additive inverse, or the negative 1 times what's being subtracted. Okay? So in this case, they want to subtract each one and make sure you check by looking at the addition. So they go through these examples with fractions and stuff. Remember, you got to get common denominators. Well, this one already does. And remember those rules about adding fractions, or subtracting in this case. Right? A lot of examples here. Now here's a case where I'm going like, man, I got a lot of stuff going on here with signs and all that kind of stuff. And I can't change the order here. I can't change the order of these subtractions to make it fit, like even put my negatives together until it's an addition. Then I can change order. So I change everything to an addition. So I go to the subtractions. Here I got a subtracting -4, which I change to adding its opposite 4. And then I'm subtracting 2, which is adding its opposite of a -2. Subtracting -5, which is adding +5. And then here's a positive +3, which is already addition. So I can do that. Okay? And, and then I do the addition. I don't see any great advantages to changing order. But you could add all your positives and you'll get 20 plus a -2, which is 18. Now, same thing happens with expressions that have variables in it. I have subtraction. Again, I cannot change the order of this thing until I have addition. So the subtracting -2ab is adding the opposite of it, which is a -2ab. Plus 7a, hey, that's addition already. -9 is plus a -9. Now it is in all addition. I can change the order. I can add 4 plus -9. I can change that order and simplify some stuff if I need to. Same thing here. And that's all they're doing really is I can convert that from a subtraction to addition. I can use the associative, commutative, distributive laws, work on subtraction too, but to get to a place where I can use the distributive law to combine like terms, I'm going to have to change the order and the grouping, commutative and associative properties, and I can only do that on addition. So you change it to an addition, and then I can change the order. I'm not going to go through all these, but that's what's going on here. Okay. Remember, if you get a -1m, that's the same as -m, because -1 means the opposite of, right? That's why I kept on putting that in here, because we're going to run into this where we have -1 times something, which is the same as the additive inverse of or the opposite of. Now, problem solving, we're looking at words that are involved with subtraction, like difference means that, minus, less than, are example of keywords that translate into a subtraction. Since subtraction is not commutative, there we go, the order in which we write the translation is very important. Unless the context indicates otherwise, the difference between 5 and 8 should translate into 5 minus 8. You have to assume that the order they give it to us is important. And if they say subtract 10 from 3, then that means we would take 3 minus 10. And that we have things in subtraction that look, you got to read it, make sure you get the context of that. And it's easy to check that and say, if I took subtract 10 from 3, would I get 7? No, right? Well, you need to remember how the order of these things come out, especially when you get variables in there, because now you can't check that. But you can always do a simpler problem by saying, what if I threw a number in there? What would it come out to if I threw a number, an easy number to work with in that variable to see if my order is correct? That's called solving a simpler problem. Well, in this case here, they're talking about world records for here. Let's read this, I guess. It's the highest parachute jump and the lowest manned vessel ocean dive were both set in 1960. On August 16th of that year, Captain Joseph Kittinger jumped from a height of 102,800 feet above sea level. Earlier, now that's been broken. That was just a couple years ago. A guy jumped from space, really, and I don't remember how high that was. And earlier in January 23rd, Jacques Piccard, I can't remember how you spell. I remember watching him on TV all the time. And oh no, that's somebody else. I'm thinking of. Yeah, never mind. And this Donald Walsh descended into this diving thing, 35,797 feet below sea level. You know, what is that? That's about seven miles probably down. What is the difference? Difference is that key word of the elevation between the highest parachute and everything else. Now remember, we use signs, right? When we're talking about elevation up here, that's above sea level. We talk about that as a positive number, and below sea level is a negative number. So we'd end up with this subtraction of 102,800 minus, they're asking for a difference of this negative number, which then translates into this addition. So we add those two numbers and get 138,597 feet. So we get rid of subtractions by changing them to an addition. Is a rule that we have. It's a law, but it's a very good strategy. There's a whole bunch of good reasons to do that. So make sure you're clear on how that happens.